Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I hope all of you are doing very good. Yes, as you know, we are completing what? We are completing our revision for second PU midterms. Okay, in this we have covered a few chapters. We have covered matrices, inverse trigonometric functions. We have covered differentiation also. Now we are moving to application of derivative. Okay, again very important chapter. Okay, there's a lot of questions, different varieties are also there, so I will try to complete this entire chapter today in this session only, and also we'll solve around 20 to 25 questions in the session from all the different type of topics. For example, what are the topics here? Topics are increasing and decreasing function. Second topic is your maxima and minima, and then the basics is also there, which is rate of change of any quantity. Okay, so we'll deal with all these concepts. So I'm gonna explain you the concepts as well, okay, wherever it's required, and I'll solve all the questions on different variety. Okay, so I hope you're prepared. I hope you have come ready to solve all the questions. Bring your pen and paper out. Okay, and if you want to have some water, because we'll complete this in one session. So be here, complete the entire chapter revision with me only. Do not have to come back again to do the same thing, okay, because there is a time crunch. You cannot keep doing the same thing over and over again. So let's start with the session. First question which is coming up is on rate of change of quantity. Okay, this is very simple question. I've started from very simple question. What is it? It's given as if what is S represents? A displacement function. S is given in terms of time t. Okay, is a cubic function 4t cube minus 2t square plus 3t plus 7. Okay, find velocity and acceleration when time is equals to 2. Okay, we all know this much. Okay, that rate of change of, we have learned this not necessarily in grade 12 only, we have learned in grade 10 also. Rate of change of displacement is called as what, bacha? Velocity. So I can write this velocity function vt as what, bacha? ds by dt. Means if I differentiate the given displacement function, what is this? Tell me. This is my displacement function. So if I differentiate my displacement function, okay, once I'll get what? Velocity function. If I differentiate again, what? I can call it as to be differentiating velocity function, or yes. So if I have to find what? Acceleration function, I'll differentiate the velocity function with what? Again time only. Or what is this called? Also called as second derivative, okay, of what? Of the displacement function, if you remember. Why, sir? Because displacement function is the first derivative. So if I'm differentiating again the velocity function, I'll get what? I'll get the displacement function second derivative, which is nothing but my acceleration. So I'm going to use these two conditions. What is this? Rate of change of quantities conditions for the velocity and acceleration to find our required result. Let's see. So let's find first ds by dt. How will that look like, bacha? ds by dt would be what? Simple differentiation of this. So 12t minus 4t plus 3t. Am I right? Yes, 12t minus 4t plus 3t at what value? So this is going to be my what? This is my velocity function vt, 12t minus 4t plus 3t. I am looking to find a velocity when it is 2 seconds. So let me just put it here. Velocity at 2 seconds would be given by 24 minus 8 plus 6. How much is that? 24 minus 8 and plus 6. This will make minus 2. So answer is 22. What is the unit? There's no unit given here, so I can write here simply unit per second. What is it? Unit per second. Okay, unit per second. If you want to take meter per second or centimeter per second, whatever it is given. There's no variable given here, so I'm taking it as unit per second. No problem there. Okay, let's find the what? Next we'll find what? Acceleration at the same point. So how will I find acceleration, bacha? At will be given by what? I can write it as dv by dt also. Simple, no need to do this. So dv I already have 12t minus 4t. Sorry, okay, one mistake, sir. A big mistake, sir. Not just simple mistake, a big mistake, sir. Okay, so I have to do this whole thing again, right? I have not taken the differentiation, right, sir? I don't know how we missed it, but let's do it again. Just quickly we'll do, no problem. What is it? If I do this, I'll get what? I'll get 12t square, right? And so I'll get it as minus 4t, right? And plus 3. So I took it as t and t at both the places. Okay, since the t value, if the t value was what, just 1, I don't have to do it, right? Because then it will make no difference. But since t value is 2, 1 square is 1, so no problem, but 2 square will be making a big difference. Okay, so let's check here. 12t square minus 4t plus 3. Okay, I did not consider the square of this term. Okay, so if I am doing this, what I'm going to get? Velocity function at t. Okay, this will be what? 12t square minus 4t plus 3. Okay, now I'm finding what? Velocity at 2 points. So same thing I'll do, but now I have to square it wherever it is, like that. What I'm getting, please check. Okay, what I'm getting, please check. So I'm getting 4 here. 12 times 4 is 48. This is what? Simply 8. Okay, 2 square is 4. 12 times 4 is 48, and plus 3. How much is that? Please check. This is 40 plus 3 is 43. Unit will remain same, unit per second. Why is that? Because there's no unit given. Next is what? dv by dt. So I'll what? Differentiate this part again. What I'm gonna get? Please check. It will become 24t. 24t I'm doing from here, bacha. Okay, 24t minus 4, right? Minus 4. 4 3 will be 0, right? It's a constant. 4 3 will be 0. So again, what I have to find? A at 2 only, acceleration at 2 only. Okay, how much is that? 24 times 2 minus 4. How much is that? Please check. 48 minus 4, right? And how much is that? 44. What is the unit? Unit is 44 units per second square. If you remember, meter per second square, or meter per second, or centimeter per second square, or kilometer per hour square is the unit of acceleration. So my answers are 44 units per second square or 43 units per second for the velocity. One mistake, I took it as t. That's why answer was incorrect. That's why I had to change it. Forgive me for this one, silly mistake. Okay, let's move on to problem number 2. Again, these questions, first few questions will be based upon rate of change of quantities only. Okay, rate of change of quantities only. Chaliye. So the volume of a cube, what's the volume of a cube? If you remember, simply a cube, okay, is increasing at the rate of 8 centimeter cube per second. So they are saying what is dv by time, right? ds, because second is there. So time is the differentiating variable. So dv by dt is nothing but 8 centimeter cube per second. How fast the surface area is increasing? So what are they asking? ds by dt. That's what the question is. How fast means with time only, right? Fast means what? Time only, right? Fast, when we say fast, means fast, I have to reach fast, means what? I have to reach in lesser time, right? So whenever we say fast or slower, with respect to time only we are talking. Okay, so how fast means differentiation of the s. What is s? S is my surface area. What is that going to be? If you remember, 6a square, bacha. 6a square, right? If the side of the cube is a, then volume is a cube, and the surface area is going to be 6 square, because there are 6 faces. So a square times 6. When the length of the edge they have given, also the length of the edge means they have given a value is 12 centimeters. 12 centimeters. Okay, they are asking us to find what? ds by dt. Chaliye, first we'll find dv by dt expression. So let's do it here. dv by dt will be what? Tell me. It will be nothing but differentiation of what? This part, a cube. So there's no variable here, a cube. It's okay. There's no variable here as a. So I can do it like this, 3a square dA by dt or not. Please see. 3a square, then I have to do for chain rule for a also. So dA by dt. Problem solved, sir. What is dV by dt value? 8. So from here I can find the value of dA by dt. So dA by dt is nothing but 8 by 3 a square. Agreed. Totally agreed. This is correct answer. Okay. dA by dt is 8 by 3 square. Now next step, last step, find ds by dt. What is bacha ds by dt? Tell me. So differentiation of 6a square. You said, sir, 6 square is the formula. So dA, how much is that going to be? 12a times what? dA by dt or not? First I did for 6a square, which is going to be 12a. dA by dt will be 8 by 3a square. So 12a times 8 by 3a square. Check a and this one square part, 1a gets cancelled. What I have left here? I can cancel 3 and 4 also, right? 3 times 4 is going to be what? 12. So I have 4 times of 8 by a or not? Please check. please check. 3 times 4 is 12. So 4 times of 8 by a or not? What is it? 4 times of 8. What is my a value? If you remember, it's 12 only. So 4 3s are again 12. How much is that, bacha? Please check how much is that? 8 by 3. So what is this value? This is my ds by dt. So I get my final answer, which they were looking for. ds by dt is what? Is 8 by 3. What is the unit going to be? Rate of change of surface area. So centimeter square per second. Centimeter square per second. This is my final answer. I hope you understand this. Okay, I'll get on one side. So please check. I hope this is visible. Okay. First we saw what was given. This was given. We assumed this side length to be a. Got the formulas for volume and the surface area. Same, we found the a value. The a value was given as 12, so we took that also. And then we did differentiation for one's volume. Got my dA by dt value. Used it in ds and dt. ds by dt, and get the answer as 8 by 3. I hope it's clear. I hope it is clear. Now next, a stone dropped into a quiet lake and wave in circles move at speed of 4 cm per second. So think about it. Waves will look like this only, na? First wave, second wave, third wave. So if the waves are moving like this or like this, what is actually increasing? Isn't that increase in wave speed, or wave speed is nothing but basically what? Rate of change of what do you call? Radius. Means what is happening? First wave had this radius, let's say small r. Second one will have small r2, let's call r1, r2, r3. The waves are having radius r1, r2, r3. So the radius is increasing, right? So I can write this speed 4 cm per second as nothing but dr by dt. I hope you understand this. I'll repeat this statement. Very important to understand this. Okay. I hope very important to understand this. So 4 cm per second is what? Rate of change of, means how fast the waves are moving. Waves are changing means what? What is happening when how can wave change? Because of the increase in the radiuses of the circles, right? So that means what? This is nothing but rate of change of radius of the circle. So that's why dr by dt is 4 cm per second. Okay. So till here we understood the question. At the instant when the radius of the circle or circular wave is 10 cm, means when they given a condition, when this is 10 cm, okay, find the how fast area enclosed is increasing. They're asking us what? To find how fast, what? Fast means they're asking us ds by dt. What is S? S is area enclosed. S is area enclosed. So ds by dt they are asking. Okay. Now tell me one thing. What is going to be ds? What is going to be the S value in this case? What is it? It's a circle only, right? It is a circle. Circle means what is the area of circle? Simple, sir. Pi r square. Very simple. Pi r square. So if I'm finding ds by dt, what I'm going to get? Please tell me. I'll get, sir, 2 pi r dr by dt or not? Yes. Yes. What is my 2 pi r? Simply, sir, 2 pi r value is what? 10. So keep 10, sir. And dr by dt, what they have given? 4, sir. They have given 4. Please multiply this. 4 times 10 is 40, times 2 is 80. My answer is 80 pi. What is the unit? Surface area change with, or area change with time. It's going to be what? Centimeter square per second. Final answer. This is my final answer. I hope this is clear. Simplest question that can be asked from this category. Okay. I hope this was visible. Moving on to question number 4. The radius of an air bubble is increasing at the rate of half centimeter per second. Means very simple. They have given here. I don't have to deduce it. They have already given. They're saying dr by dt is radius change. Please check here. Radius change means dr by dt is 1 by 2 centimeters per second. Okay. At what rate is the volume of the bubble is increasing when the radius is 1? Okay. So simple. Take the radius. This is given 1. They are asking us to find what? dB by dt. At what rate the volume of the bubble is increasing? So what is it? dV by dt they are asking. Correct. How will I find dV by dt? So what is this? Bubble means what? It will be spherical in nature. Correct. This is having volume means spherical in nature. A bubble will have a what? A spherical nature. Okay. Correct, right? Spherical nature means what is the volume? V equals to 4 by 3 pi r cube. I'm not going to solve this question. You have to find what? You have to find dV by dt. Get this expression. put the known values of r dr by dt, okay, in this. So this is going to be your homework. You have to solve it and give me the answer in comment. So how are you going to comment? So comment answer for question number 4 is what, sir? Question number 4 answer is whatever you're going to get, okay? Very simple. Very, very simple question. I want this answer from all of you, okay? All of you should, whoever is watching this video should give me this answer. Very, very simple, okay? You can solve it without using pen also, right? It'll be 4 pi r square, no, because 3 and 3 will cancel each other. 4 pi r square with dr and dt, use the values and get the answer. Give me the result. I'm moving on to question number 5. Chaliye. The total cost Cx, a function of the total cost is given by Cx, okay, in rupees associated with a product, okay, production of x units, okay. Obviously the function is what, in x, so they're talking about total cost of production for x units is given like this, 0.007 x cube minus 0.003 x square plus 15x plus 4000. This is my function, okay, this is my function, okay. Chaliye. Now they are asking find the marginal cost when 17 units are produced. So they have given what, x value is 17, right? Because x was the number of units in the production, and they have given 17 as the number of units, means x is the 17, x value is 17. What is the marginal cost? First learn that part. Marginal cost is nothing but what, bachcha? Tell me. It's the instantaneous rate of change of what? Of the total cost. Total cost at any particular value of production. It can be x, y, anything, okay? Means whatever total cost of production for any value, means let's say it is 15, 12, whatever it is. So you have to find the instantaneous rate of change. Now remember, what is the instantaneous rate of change? It is nothing but my differentiation, okay? Because otherwise I can write change as average also. The change can be average also, but what is this? Marginal cost is instantaneous rate of change. For that reason, what I'm going to do, I'm going to write this as marginal cost m, let's say x, mx will be given by what? dc by dx, okay? Differentiate it. How much I'm going to get? 0.007 times 3 x square, okay? Again I'll get what? I'll write it as 0.006 only, 0.006 x, and this will be simply 15, okay? Now in this, what you have to do? Put the value of 17. So if you find it, m of 17 will be what, bachcha? Please tell me. This is simply what? 0.007 times 3 times 17 square is how much? I'll write x as 17 because the number of units given is, in this case, is 17. So 17 square will be 289 and plus 0.006 times of 17, okay, plus 15, okay, plus 15, okay. I hope you can solve it from here. Please do the calculation and give me the answer over here also. Do the calculation here. You'll get a number over here and number over here, and give me the solution here. Give me the total cost here. So comment the solution. I've given all the steps. Comment the solution or the final answer. Okay, for which number? For question number 5. For question number 5. Okay, just comment this part. Okay, rest all I've done. Okay, let's move on to the next problem. You can do the calculation from your side. Yes. Now, so first what we covered? We covered rate of change of any quantity with respect to what? We talked about instantaneous rate of change, and with that we solved questions. 5 questions we have solved on rate of change. Now we are moving to second subsection of the application of derivative, which is nothing but increasing and decreasing function. Means when can I say, if I have a function defined like this, okay, if I have a function, let's say defined like this, y equals to fx, okay, then when can I say this function is increasing in nature, okay, decreasing in nature? We also have something called as strictly increasing or strictly decreasing. What is the meaning of this, sir? I'll tell you. So for example, if I draw, let's say y equal to cos x, or let me draw y equal to sin x. Please check here. Doesn't look like it, sir. Doesn't look like it. Let me rechange Okay, let me change this graph. This is my y equal to sin x. Okay, correct. Now check here. If you look at this function completely, then what are you going to say? Sir, it is decreasing. What is this value? If you remember, this is minus pi, this is minus pi by 2, this is 0, this is pi by 2, and this is pi. Am I right? Okay, now please check, from this value, from this part it is decreasing, increasing, then again decreasing, sir. So this function y equal to sin x in the domain minus pi to pi, it has dual nature. So both increasing and decreasing is there. But if I can, restrict the domain, if I can only talk about this part, let's say, only this part is asked to be kept relevant. So if you see this graph, I'll draw it again. It looks like this. Correct? Looks like this. What is this? It's increasing in nature. Means if we talk about y equal to sin x, in what domain? Minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. What happens? It is strictly increasing, sir. It is strictly increasing, sir. Okay. I hope you understand this. Basically, I can have a case where my function can be strictly increasing, strictly decreasing, or combination of both. So basically all the three combinations can be existing in the same function, or it can be restricted by bifurcating the domain. Okay, so this is just to make sure, give you an idea about this. So I'm going to erase this now and write the property how to determine it. Like, this is the condition I explained you. A function can be increasing, decreasing, or both. Okay, now I'm going to explain you how to find it out, or how to reach the conclusion that the function is increasing or decreasing or not without using the graph. Okay, chaliye. So let me erase this. So we'll try to reach the conclusion where we'll talk about how the function is increasing or decreasing without use of the graph. Okay, chaliye. So what happens if our function y equal to fx? You find what? You find the first derivative given by y dash. If this is greater than 0, then what is it? Simply function fx is increasing. Actually what happens is, if there is only greater than 0 symbol, we call it as to be strictly increasing. Okay, if there is an equality sign here, I'll call it to be simply increasing. Understand this. Okay, if I have an equality sign here, increasing. If there is no equality sign here, I'll call it to be strictly increasing. So don't worry about that part right now. Just know this, that greater than 0 means increasing. If the derivative is coming to be less than 0, I'll call the function fx to be decreasing, sir. Call it to be decreasing, sir. Okay, so this part is clear. When can I call a function to be increasing and decreasing? Okay, now next thing is, so whenever we'll talk about, let's say, in an interval, in an interval, talking about in an interval means if I have an interval defined, okay, then how can we decide whether the function is increasing or decreasing, okay, chaliye. So I can see this, let's say, let's say I have a function defined like this, okay, x minus 1, x minus 2. This is what? My derivative of the function. What is it? Derivative of the function, okay, is defined like this. Then what I can take? I can take a straight line, okay, I can take a number line basically and plot what is these two ends called as negative infinity to positive infinity, okay, negative infinity to positive infinity, and I'll write this two critical points. What are the critical points? If you put these two values, if you put the derivative, first derivative equal to 0, you'll get two critical points, x equals to 1 and x equals to 2, right? Now put it here, 1 will come here, 2 will come here, okay. Now put any value after 2 in the derivative. So put 3 minus 2 will be what, bacha? Positive, and 3 minus 1 will be again what? Positive. So I'll write here the sign as positive. Before 2, think about it, this will be negative, this will be positive. So negative into positive is negative. Before 1, this also is negative, this also is negative. So again what? Positive. So I can say in the interval 2 to infinity, the function is increasing. You see this? Interval 1 to 2, function is decreasing, and infinity to minus 1, minus infinity to 1, not minus 1, is again decreasing. So By looking at the real number, we can talk about the intervals. This is very important. Why? Because when we deal with maxima minima, we'll have to use this same understanding. Okay, so we'll see in the session today only, but we'll see how this is applied to those questions also. So this is very important. What are the key points? First step is to find the derivative. Okay, so find the derivative. Next step number 2 is find derivative, put it equal to 0. Why are we doing this? To find critical points. Okay, and then what are you going to do? Third step is draw number line. Draw the number line. And what is the last step? Check the trend by putting values after or before the 1, 2 or whatever is the critical points. Okay, chaliye, moving on. Okay, now this problem, so that the function given by, I have taken 4 functions here. Fx equals to 7x minus 3, fx equals to 3x plus 17, fx equals to e power 2x, and the fourth function is given like this. For all these 4 functions, you have to check whether it is strictly increasing on the real number or not. Okay, so let's check for the first one over here only. Check here. So that first one is y equals to what, bacha? 7x minus 3. Take the y derivative. 7. Is 7 more than 0? Yes. So what is it? Strictly increasing, sir. Strictly increasing, sir. Yes. Otherwise, if you want to see, it's a straight line, right? Straight line is always increasing only, but not necessarily. If the straight line is like this, it is decreasing also. Okay. But for that, you'll have a negative slope. Okay. You know all this slope and all because you have learned in quadrant geometry PU1, also in grade 10 we are learning the slope formulas and all. Okay. Second function, same thing again. Y equals to 3x plus 17. What is y dash? Simply 3 greater than 0. What is it? Strictly increasing. For all the real number, strictly increasing. Third one, please check here. Third one is what? Exponential function y equals to e power 2x. What is my y dash? Y dash is going to be e power 2x times what? 2. How much is that? 2 times of e power 2x. 2 times of e power 2x, right? Not visible. Let me rewrite this. E power 2x. Exponential function is always positive. This is 2, means this is again e greater than 0. So what is it? Strictly increasing. Other way to look at this is plot the graph and see the trend. Okay, but without the graph we can write it like this. Fourth one, x cube minus 3x square plus 4x. Okay, so let me write it here. Y equals to x cube minus 3x square plus 4x minus 3x square plus 4x. What's the first step? Find the derivative. Please find the derivative. So 3x square minus 6x plus 4. Am I right? Okay, I can see a square term and a term with x, so I will try to make here a perfect square. How can I do that? Let's see. So x square minus 2x I will get, plus 4 is outside. Okay, so I have a square and I have 2ab. Okay, so what is missing here? Please check this. I have x square, so which is a square, and minus 2 times of x is there with 1. Correct, right? 2 times of x is there, so 2 times of x into 1 is minus 2x. So what is my ab term? A is x, b is 1. Please check. B is 1, 2ab. So I'll write here plus 1 square minus 1 square. Why is that, sir? Because I want to make a perfect square out here. Okay, so if I'm adding something extra, I have to remove that part also. So why writing as 1 square? Because I wanted to make the formula form. I'll get what? 3 times of x minus 1 the whole square minus 1 plus 4. This is clubbed together to make this x minus 1 the whole square. Multiply 3 with minus 1. What are you going to get? Please check. So it will become what? 3 times of x minus 1 the whole square minus 3 plus 1 plus 4. How much is that? 3 times of x minus 1 the whole square plus 1. This is my y dash. This is my y derivative. Please check here. Square means always a non-negative number. It can be 0 also, but non-negative. Multiplied with 3. Again, 3 is a positive number. So this can be either 0 or non-negative. So it cannot be what? A negative number. What about 1? 1 is a positive number, means total. If you add a positive number with any other positive number, it will be what? Possible, you know. So greater than 0. Again what? The given function, this is the case 4. Given function is what? Strictly increasing. So I hope I am able to clear your doubt or all your backlogs about your increasing and decreasing function from this one question. I've taken one question with 4 parts to explain you all the different varieties. Okay, so okay, let's move on. Again, few more questions are on intervals. Let's see. Find the intervals in which the following functions, okay, option A is increasing, strictly increasing, and option B is strictly decreasing. Strictly increasing and strictly decreasing means what? It means if I take this as the function cannot be like this, because this function, you look at it, increasing, okay, not like this. I wanted to show you a straight line over here, so let me just draw it again. So like this, this and this, okay. 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 So look at this function, increasing, constant, increasing, increasing, constant, increasing. Is it the case of strictly increasing? Can we call it to be strictly increasing? No, sir. You cannot call it to be strictly increasing. Why is the reason? Because it is strictly increasing means what? The function has to be always like this. There is no constant, nothing. Okay. Decreasing also the same way. Always like this. It cannot be like this, and like this. None of these factors are possible. Only, so there cannot be a equal to sign. There cannot be a equal to sign. There cannot be a constant value. So always increasing. If x is increasing, what is happening? Basically, what it means is, for increasing function, if x increases, y is always increasing. Okay. If x increases, y is always decreasing. This is for decreasing function. I hope this is clear. X increases, y increases, so increasing function, x decreases, y decreases for decreasing function. Chaliye. Okay, let me just complete this part for you. Okay. Okay, so find the intervals in which the following functions A strictly increasing and B strictly decreasing. Means I have to check in the same function whether both conditions are existing or not. Okay, chaliye, let's solve the first part. Part 1. So part 1 will be, what is my function? Y equals to x square minus 4x plus 6. Yes or no? What is the first step we do in the finding the interval with the help of intervals? We have to find the derivative. So please find the derivative here. What I'm going to get? Y dash equals to 2x minus 4. 2x minus 4. Next step was what? To figure out the critical points. So put it equal to 0. Y dash equal to 0 means what? 2x minus 4 equal to 0. So what is x equals to? 2. X equals to 2. Now for that point, using on the number line, plot it on, plot the critical point. So this is going to be minus negative infinity, positive infinity. How much is the point is? 2. Now what I'm going to do, the last step, put any value after 2 in the derivative and check the trend. After 2, I can put 3. 3 times 2 will be what, bacha? 6. 6 minus 4 is positive. Before 2, please check. I'll put 1. 2 minus 1 is what, bacha? 2 minus 1 is 2. Minus 4, negative. So this is the trend. Over here the function is increasing. Over here the function is decreasing. Okay. Can I take 2, sir? Can I take 2? What about 2? If you put 2, it will become 0. Okay. So I said no. Strictly increasing means it has to be non-equal. We cannot take the equality sign. So I will not take 2. So I wanted what? First part was strictly increasing, sir. What is the answer? What is the interval for this? 2 to infinity. Infinity is always open. What about 2? Open only, sir. Please understand this. Because I want, what is my answer? Strictly increasing. If the question was only increasing, if the question was, understand this, only increasing, then I'll write it as 2 enclosed with infinity. Okay? 2 enclosed with infinity. But they are asking what? Strictly increasing. So I will have to write it as open only. So please let me erase this, not the answer. Just wanted to show you. Because what happens in the question, they'll give you a very simple question for 1 mark. Okay? Nothing will be given, just any, thus the bracket will be different. You will not be able to figure it out, lose marks there. So understand this, if it is strictly increasing or decreasing, the equality can be present here, can't be present here. Okay, but if it is just increasing, decreasing, we can take the closed bracket also. Chali, option number B, bacha. Option number B. Okay, strictly decreasing. Strictly decreasing, what does it tell me? Before 2, so I will write it as minus infinity to 2. Minus infinity to 2. This is my answer. So first part is done. Okay, first part is done. Next question is 4x cube minus 6x square. So I will solve it over here. Okay, I will solve both the parts here. I will not give any one of them as homework, just to make make you get better at this point. Okay, so I'm gonna do the differentiation on this side. What's the condition given? Y equals to 4x cube minus 6x square. Y equals to 4x cube minus 6x square minus 72x minus 72x and plus 30 and plus 30. What is my derivative? Tell me here. Derivative will be what, bacha? Please check. 4 times 3 is 12x square. This is going to be what? Minus 12x, and this is simply what? Minus 72. 30 will be 0, a constant. Please check here. So 12x square minus 12x minus 72 equal to 0. Next is what? Find the critical point. Can I take something common? Yes. Take this common, 12. So x square minus 1, so simply x minus 6. Correct? Minus 6 is correct. Take this as y dash. Put y dash equals to 0. What I'm going to get? Tell me. 12 times of x square minus x minus 6 equals to 0. Okay. Factorize this. I hope you know how to make this factor. X minus 3 and x plus 2, I guess. Okay. X plus 2, I guess. Okay. Please check. X times of x is x square, minus 3 times of x is what? Minus 3x, and 2 times of x is what? Plus 2x. So minus x, and minus 3 times of minus 2 is minus 6. Okay. If you're not sure, do one thing, split x in terms of minus 3x plus 2x. If you're not sure how I got this this factorization, just split this term x square minus x minus 6 as minus 3x plus 2x, okay, instead of x, and then take the common thing. So answer is 12 times of x minus 3 times of x plus 2. What is the critical point? Minus 2 and plus 3. If we equate it, 2 will become negative and this will become 3. Okay. Now what is the next point? Draw the number line, please. What is the answer? Starting from this end, minus infinity goes till infinity. This goes to minus 2 will be over here. This is my 3 over here. What's my function? What is my derivative? Please check here. My derivative is y dash equals to 12 times of x minus 3 and x plus 2. Okay. So I'll check after 3 first. I'll check after 3 first. After 3 I'll take it as 4. I can take here what value? 4 value after 3. So 4 minus 3 will be what? Positive. Please check here. So I'm taking y derivative at 4. So it will be positive in this case. And what will this be? Again positive. So answer is positive. Yes. Okay. Now what about before 4? Before 4 I can take it before 3. I can take it as 0 also. Please take 0. Before 3 and after minus 2. Take it 0. So this will be what, bacha? I'm taking y dash at 0. This will be what? 12. So 12 will be what? With the minus, so negative. Correct. Now 0 minus 3 is minus 3, so negative. This is what? Again positive. So plus 2, right? So positive means what? Plus into minus is what? Negative. Okay. So minus, negative. Okay. Now take before minus 2. So I'll take it as minus 1. Minus 1. What is that minus 1? This will be what? 12 times of minus 1 and minus 3 will be minus 4. This will be what? Minus, what do you call? Minus 1 and 2. Minus 1 and 2 will be what, bacha? So again, plus 1. How much is that? This will be minus only. This will be minus only. Please check. 12 times of 4 times of 1 is minus only. Okay. So before 3, it is all decreasing only. Okay. Please check. After 3, so this will is basically increasing. This is decreasing. This is decreasing. So what is the interval for decreasing and increasing? Okay. Decreasing, increasing will be what, bacha? Tell me. So increasing will be, strictly increasing will be what? Option A, 3 to infinity, and B will be what? Strictly decreasing. How much is that? Minus infinity to 3. Okay. So even though I have 2 intervals here, but it's coming like this. See, both are decreasing, no? So starting from negative infinity to plus 3 is what? Decreasing only. Okay. Both are negative. So let me cross check. If I take any other value, is coming like this. So minus 3 if I take, yeah, minus 3 if I take is minus 6, and this will be minus 6. Okay. All right. Okay. There's a mistake. That's what I thought. What's the mistake? What's the mistake here? I have made a blunder. Tell me what is the mistake first. I'll tell you. I've taken minus 1. Minus 1 will come before minus 2? No, sir. It has to be. It will be between here, right? I have to take a value which is smaller than minus 1. How much is that going to be? Tell me. This will be what? Minus 3. Okay. So that's why it was coming like this. That's why I thought, how should it come? So let me take the value minus 3. Why minus 3, sir? Because before minus 2, right? So a number before minus 2 will be minus 3. How much is that? 12 times of minus 3 will be what? This is minus 6. This is what? Minus 1. Minus 1. So how much is that? Again positive. So this will be positive, sir. Okay. I hope you understood this. There was a mistake from my end. Okay. Alright. So strictly increasing 2 places. This from minus 2. Okay. See here. Strictly increasing means what, bacha? Okay. Please check here. 3 to infinity. Okay. And what is it? 3 to infinity also. And this part also minus infinity to minus 2. This is also strictly increasing, and for strictly decreasing what we have, B part, please check, minus 2 to minus 3. Minus 2 to minus 3. Minus 2 to 3. Okay. This is my strictly decreasing part. So again a mistake I have made. I've taken minus 1 because what is the thing I taught you? Before minus 2 you have to take, right? What is the number before minus 2? Minus 1 is after minus 2. We can't consider that. So I have to take minus 3. So I've taken minus 3 now, came as positive. So plus minus plus. Forgive me for making this silly mistakes. So 2 of the mistakes are there in the session today, sir. Okay, forgive me, sir. Moving on, question number 8. Question number 8, taking with the trigonometric function. Okay, we have to check whether it is increasing in this domain or not. 0 to pi by 2. Please check. So first we have to find the derivative. Then we'll talk about this interval 0 to pi by 2. Okay, let's take the derivative first. So I'll have what, bacha? Y dash will be what? I have to apply this derivative over here. Quotient rule I'll apply. I'll apply what? Quotient rule I will apply over here, and this will be simply 1. Please understand this. Theta will be what? D of d theta will be what? For theta 1 only. Okay. Now moving on, use the quotient rule over here. So I'll do for 4 sin theta will become what? 4 cos theta. The numerator part will be like this. I'll keep this as it is. 2 plus cos theta will be as it is. Okay. Now what next? Put a minus sign because I'm using a quotient rule. I'll keep 4 sin theta as it is. And do what now? Differentiate 2 plus cos theta. So it will be 0 minus sin theta. Yes or no? A minus sign is here. Divided by 2 plus cos theta the whole square. Yes or no? Yes. Okay. Now what, check this out. So I'll get what? I have this, expand this. So I'll get 8 cos theta. Okay. 8 cos theta. 4 cos theta into 2 is 8 cos theta, and this will be plus 4 cos square theta or not? Yes. And what is it going to be? Plus minus 4 into plus 4. How much is that? 4 sin square theta or not? Yes. Divided by 2 plus cos theta the whole square minus 1. Okay. Now please check. 4 cos square plus 4 sin square. I can take 4 common. It will become what? Simply what? Please check. I can write it here only. So I will not write entire part. I'll just take this. Please see this thing. I can take 4 common. It will become what? Cos square theta plus sin square theta. So this will be what? 1, right? So 4 times of 1 is how much? 4 times of 1 is 4. So I can rewrite this as y dash equals to what is it? 8 cos theta plus 4 upon 2 plus cos theta the whole square minus 1. Am I right? Now take the LCM again. So 8 cos theta plus 4 minus 2 plus cos theta the whole square divided by 2 plus cos theta the whole square. Yes, I'm taking with minus now. What I'm going to get? Please check. Do the expansion. 8 cos theta plus 4 plus, okay, minus 4 plus cos square theta, okay, plus 2 cos theta. Yes or no? Yes or no? Please check here. 2 is 4, cos theta is cos square theta, and this will be not 2, 4 cos theta. Because 2ab, right? So 2 into 2 will be 4 times cos theta will be plus 4 cos theta. Okay, now please check here. I can simply change the sign because of this minus sign outside, and this will be what, bacha? This will be minus, this will also be minus, this will also be minus. Please understand. So I can rewrite this sign as negative, minus and minus. Because of this minus sign outside, please check here, 2 plus cos theta the whole square. Okay, what I'm gonna get? Please check. 4 minus 4 gone. Yes, 4 minus 4 is gone. Okay, now what is left now? 8 cos theta minus 4 cos theta. How much is that? 4 cos theta. Okay, and how much is this? Minus cos square theta. Minus cos square theta. Okay, upon 2 plus cos theta the whole square. Okay, this is my y dash. I have to check what? Increasing. I have to check whether it is increasing in this domain 0 to pi by 2 or not. Now please check. Please have a look. Let me write the domain here. Write the domain here. Theta belongs to what? 0 to pi by 2. 0 to pi by 2. So if I take just 0 to pi by 2, let's say open it. If I take 0 to pi by 2, first open. We'll see here first. So if you see in 0 to pi by 2, what is the trend of the cos theta? It is what? A number, okay, less than, it is decreasing in nature obviously, but it is a number which is less than 1 but positive number. So cos theta will be what, bacha, tell me? Cos theta will be what? Cos theta will be a positive number, okay, but less than 1 or not. Cos 0 is 1, but and cos 90 is what? 0. So between 0 and 90, what will happen? The number will be positive but less than 1, okay, because it is starting from 1 and going to 0. So the number is less than 1, but what? But it is positive. So think about it. 4 cos theta will be what? 4 cos theta will be positive. Positive number multiplied with cos theta is what? Positive. I established here. Cos theta is positive. So 4 cos theta will be what? Positive minus. Please check here. Cos square theta. If you square a number, which is less than 1, square a number which is less than 1, what are you going to get? A smaller number will be 0.25. Yes or no? If you square a number which is positive, less than 1, you'll get what? A number smaller than that. So 0.25. So same number if you square again, a number positive which is less than 1, you'll get a smaller positive number. You'll get what? A number smaller. You'll get a smaller positive number. Please see this. You'll get a smaller positive number only. Okay. And this will be again positive. Please check. A square of any number is positive. This is positive. This is smaller, very small number. A positive number minus very small number will be what? Again positive only. And denominator is what? Again positive. So this positive by positive means what? Positive only. Positive means what? Greater than 0. So I have established what? The derivative is greater than 0. I have established derivative is greater than 0 where? In 0 to pi by 2. So it will be greater than 0 in this also. Okay. Greater than 0 means what? Greater than 0 means what? Increasing function. Okay. Simple. Let's see here. Derivative was here. We know that cos theta in the interval 0 to pi by 2 will be what? A positive number but less than 1. Positive but less than 1 means what? This will be a positive number, a very big positive number, because 4 times of cos theta will be bigger number. Square if you do, you'll get a very small number, small positive number. Difference will be what? Again positive. Positive by positive will be positive only, so greater than 0. If the derivative is greater than 0 means what? Increasing function. We have to prove what? Increasing function in that particular domain. I hope this is visible. Okay. Chaliye, moving on. Question number 9. Question number 9. Prove that the logarithmic function is strictly increasing. Okay. कर लेते हैं. Y equals to log x is the function, right? Logarithmic function. Okay. We have to check whether it is increasing or not in this interval. Derivative will be what? Tell me the derivative will be y dash will be what? 1 upon x or not? Okay. 1 upon x or not? Now think about it. If you take x from 0 to infinity, 0 to infinity means for all positive numbers, what will happen? For any positive number, this will be positive only, no? Right? So what is the function? Always increasing. Always increasing. Strictly increasing. Okay? So it is proved. Therefore, log is strictly increasing in what? Simple. moving on. Question number 10. Find the least value of the of a such that function fx is x square plus ax plus 1 is strictly increasing. Excellent question. Excellent question. The function is given as y equals to x square plus ax plus 1. Okay. What do we know? First thing is what? Derivative 2x plus a. Okay. Now this has to be what? Positive. If you apply like this, you'll get a in terms of x, but there is no x given here. There is no one x value. If you apply the rule of increasing function, we have to check what? Increasing function, right? If you apply the rule of increasing function, you'll put what? Greater than 0, you'll get a in terms of x, but x is not given. Interval is defined like this. So I have to do some modification. Please have a look. What does this mean? 1 to 2. It means x lies between 1 to 2 or not. Interval 1 to 2 means x lies between 1 to 2. How many points? Infinite number of points. Okay. So I want what? I want to know, I don't want to know x value. I want to know 2x plus a will lie from where to where. So I will do what? Modify this. So multiply 2 on both sides. So 2 times of 1, 2 times of x, 2 times of 2. What are you doing, sir? I want to know the trend of this, right? I want to know whether this is positive or negative, whatever it is. Okay. So I want to know, I don't have x value here, but I have the range of x. Okay. So I can take, domain of x. Okay. Or a value of where the x is moving, 1 to 2. Okay. So how I'm going to get this? 2x plus a. So multiply this x from 1 to 2 as 2 times of 1 and basically multiply 2 on the both the inequality. You'll get what? 2 less than 2x less than 4. Is this what we're looking for? No, so we're looking for 2x plus a actually. So there is a 2x here, so add a on this. So 2 plus a less than 2x plus a less than 4 plus a. Yes or no? It means 2x plus a, which is nothing but what? My derivative should be what? Should be greater than 2 plus a and should be less than 4 plus a. Yes or no? What is 2x plus a? My derivative, y dash. What is the condition? Y dash should be greater than what? 0. Should be greater than 0. So what is this? What y dash, no? And y dash should be greater than 2 plus a. Basically, what I can reduce here, no? That 2 plus a should be greater than 0. Think about it. Y dash should be greater than 2 plus a and it has to be positive also. It means this number has to be positive also. So again, greater than 0 I can put here. What I'm going to get? Okay. A greater than what? Minus 2. Okay. If I'm writing only strictly increasing, right? Answer is this only. Answer is this only. If it was increasing, I can put equality sign also. Answer is this only, sir. Okay, moving on. Because this was not enclosed, check here. It was not an included interval. If I take a included interval over here, if I take 1 to 2 also, I can put equality here and here. Then it will become what? Greater than equal to minus 2. Please understand this. If it was square bracket, then again I'll put here equality everywhere. Then I'll have what? Greater than equal to minus 2. But not the case in this particular situation, in particular example. Okay, moving on. Good question, because not calculated, but you have to use your mind to solve this problem. Okay, find the interval in which this is increasing. Okay, what is the one thing that we do? First thing is find derivative. So let's check here. Y dash will be what, bacha? Differentiation of x square e power minus x. How am I going to do? Product rule. So you keep x square as it is. I'll do e power minus x will come e power minus x times of minus 1. Please check. I kept x square as it is. Okay, x and then e power minus x differentiation will be what? E power minus x times of minus 1, because minus x will be differentiated at minus 1. Then what? Next plus sign will come. Keep e power minus x as it is. Yes or no? And what is going to be x square differentiation? Simply 2x. Simply 2x. Now check here, what is it? I can take, so I will rewrite this. I'll rewrite this over here as y dash equals to x square. So there's a minus sign. So minus x square e power minus x plus 2x e power minus x. Okay, simple. All right. Now I have to take the interval. So let me check here. I can take e power minus x common. E power minus x with x I can take common. What's left now? Only minus x is left and plus 2 is left. Please check. I have taken e power minus x and x common. So what is my factorization now? X e power minus x. Please check. I'm looking for interval, right? So I have to equate it to 0, no, to get the critical point. X e power minus x, 2 minus x. Okay, now I have to equate it to 0, put it equal to 0. What are you gonna get? Please check. Okay, I'm gonna get x e power minus x times of 2 minus x equals to 0. So what is this? Okay, first value is x equal to 0. How can this value be 0 if x is 0? Because e power minus x is never 0. Okay, x is 0, one thing is there. Next is what? 2 minus x equals to 0. So what is it? X equals to 2. So I get 2 critical points. I get 2 critical points. What is this? Please check here. My critical points are 0 and 2. Is it right? 0 and 2. Okay, this is 2 bacha. 0 and 2. All right. What is the differentiation of the function? X e power, this is my derivative, right? X e power minus x, 2 minus x. Let me write it here to see the trend. Y derivative will be what? X e power minus x, 2 minus x. Okay, 2 minus x. So let me check. First, after 2, let's take a number 3. So I'm taking the derivative. I'm checking the derivative sign at 3. It will be what? Positive, positive. And what will this be? Again positive. Okay, negative. 2 minus x, right? So negative. Okay, please see here. 2 minus 3. 2 minus 3 will be what? Negative. So this is negative. Okay, correct. Before 2, I can take 1 between 2 and 0. 1, check here. Y dash at 1. So again positive. This is to always positive. What will this be? 2 minus 1. So again positive. Please check here. Plus, plus, plus. So positive. Positive. Before 0, I can take minus 1. How much that will be? This will be minus. So minus. Correct. Minus x will be minus. So minus 1. This will be always positive. Okay. What about this? 2 minus of minus 1. How much is that? Plus 1, right? So this is minus, plus, and this is what? Plus again. Plus again. So again, what is the answer? Negative. So this is negative. Means what? This is decreasing, increasing, and decreasing. What are they asking us? Find the interval which is increasing. They are asking us for increasing, right? What is the increasing interval? Only this part. So 0 to 2. Okay. Increasing in 0 to 2. We have this as answer. So increasing. Y is increasing in 0 to 2. Hope this is clear. Please have a look. Please have a look. First derivative we found using product rule. Equated to 0 to get the critical point. Plotted on the number line. Check the signs. This is what we do using first derivative. What we do? We check the sign change. Okay. Chali. Okay. Find the maximum and minimum values, if any, for this thing. Okay. Great. Excellent question. Okay. Maximum value for this function. What is the function here? Check here. Y equals to x. What's the interval defined? X belongs to 0 open, 1 open. What's the maximum value of x? If x tends to 1, okay, what will y tend to? 1. But will y be equal to 1? No, sir. So no maxima. Maxima will be no there. Okay, no maxima. Okay, what about next one? When x tends to 0, what is my y value? Y will also tend to 0. Again what? No minima. So this particular question will have no maxima, no minima. Why, sir? Because if it was like, let's say like this 0 to 1, then I can check the answer to be minima is 0, maxima is 1. But here 0 and 1 are not part of the interval. It means I cannot take that. So neither minima or nor maxima exist in that particular question. Y equal to fx. Okay. So answer is clear. No maxima, no minima. Okay. Now find the maximum. So basically what we have done, no, we have covered 2 parts of our chapter AOD. First part was what, bacha? First part was rate of increase, rate of change of function. So rate of change of a quantity we learned, sorry. And second one we learned about increasing and decreasing function. We saw the question with respect to what? When we have to check only the trend or the interval. Okay. So we solved questions on all the categories. So mostly I think 10 questions we have solved now so far. Now rest of the questions will be on maxima and minima. So let's solve these questions also. Find the maximum and minimum values, if any, for the following functions. Okay. Modulus function, simplest ever. How will you solve this modulus function? Tell me. For modulus, so what I do now, I don't take anything, just take the graph. First y equal to mod x I will take. What's the graph gonna look like? Now mod x plus 2 means graph is shifting towards left transformation. Second one is what? Mod x plus 2. So graph is shifting towards left at what point? At point 2. Yes or no? Check, no? If you put x goes to minus 2, what will this be? X minus 2 plus 2 will be 0. So yes, this is the point. So now, for now, this graph is gone because I had taken the graph to be on the left hand side. Okay. Now the last part. Minus 1 means this is a transformation, plus 2 is transformation across x, but minus 1 is transformation across y axis. So I have to move this graph where? Across 1 unit downward. So it will be same thing but over here. This is the graph for y equal to mod of x plus 2 minus 1. Think about it. Please think about it. Plus 2 is transformation is x in x. Whenever I add a value 1 or a unit, I move it across left. Okay. Move the function across x, across the negative x axis. So I get what? The function changed to a minus 2 point. Then I am moving what? Minus 1 across the y axis. So 1 unit down. This is what point? Minus 2 and minus 1. Okay. So now tell me, what is the minimum value of this function? There is no maxima, because if you keep going on the right side, it will never go. You will reach infinity. Left side also you go, reach infinity. What is the minimum point? This is the minimum point, minus 1. So what is minus 2? Because minus 2 is the x value. We are asking minimum means we are asking the minimum of y. What we are asking? Please check here. We are asking minimum of y. What is the minimum of y? Minus 1, sir. Simply minus 1. So what is the answer? The minimum value for this is minus 1. This is my answer, sir. Check for this sine 2x plus 5. Okay. What's the range of sine 2x? Minus 1 to 1. So the maximum value of sine 2x is what? 1. So acha, both we asked, no? What is maximum value? There is no maximum here. Maximum does not exist. Maximum does not exist. I hope you understand this. They are asking both maximum and minimum value. Okay. I thought only minimum they are asking, but they are asking both maximum and minimum value. So maximum does not exist in this case because it will go to infinity on both the sides. Minimum is minus 1. Okay. Minus 1. What about this one? What about this function? What is the maximum value? Tell me here. So maximum of this will be what, bacha? 1. And then what will be hx maximum? So I'll get hx maximum when the sign is 1. So 1 plus 5, how much is that? 6. And what is my minimum? What is my hx minimum? When this is minimum, how much is that? Minus 1. Minus 1 plus 5, how much is that? 4. So maximum value is 6, minimum value is 4. So here's the answer. Don't have to write there. Answer is here. Both the answers are here. 6 and 4. Maxima is 6, minima is 4. Moving on. Now let's learn the concept part again. We'll talk about maxima, we'll talk about minima, we'll talk about local maxima, local minima, and absolute maxima, absolute maxima, minima. Means we'll talk about all this concept, which is the last part of your AOD, okay, in detail. Okay, then we'll solve the questions on this. Chaliye. So first we saw in the previous two questions, first we saw what is the meaning of maxima, minima. What is the meaning of maxima, minima? When the for what value of the x the value will reach with the function, highest value or the lowest value. Okay. So over here highest value was not defined, lowest was minus 1. Over here highest value was what, 6, and lowest value is 4. Okay. Now so there's something called as, first of all, let's see the maxima first. So I'll draw a few graphs, and again I'll erase this also if not required. So please see. So if I have a function y equal to, let's say, fx, okay, y equal to fx, and the graph is drawn like this, the graph is drawn like this, then this point will be called as point of maxima. This point will be called as point of maxima. How can we define it? How can we define it? For any neighborhood points. Let's say this point is my point A, point B, and this is my point C. Point C. A, B, C is the 3 points, A, B, C. So what is the condition? F at the point C should be greater than F at the point A, and F at the point should be greater than F of the point B. Means function value at point C should be highest in the neighborhood of A and B. The maxima will be like this. Again for the minima what will happen, bacha? Reverse will be there. Reverse. The function will be reversed, right? So if I take the same points over here, and over here, what will happen? For the minima part, this is maxima part, right? This is for maxima, sir. What about for minima? For minima, what we'll have? We'll have f of a, sorry, f of c, no? F of c, right? Yeah, this is point C. Please check here. F of c should be less than f of a and also less than f of b. Correct, right? At this particular point, look at the white curve. At this particular point, what is happening? This value is the minimum, right? So if you take the f of a is more than f of c. F of b is also more than f of c. So when that is true, then we'll call it as point of minima. So far we have defined what is the meaning of maxima, what is the meaning of minima. Okay. Now what is something called as absolute maxima? Means, so if I draw a function, no, if you see a function like this, okay, it means this function has a minimum value also, a maximum value also, minimum also, maximum also. Okay, so same function can be, let's say phi equals sin x or y equals cos x, can have both maxima and minima also existing at the same time. Okay, then which will call what? So basically the function will have what? So what we do, no, what we do is at a point where this condition is valid, minimum condition is valid, we call that point to be local minima. Local minima means at that neighborhood, in that neighborhood over here, it is achieving a minimum value. Again, when we go to this point, I'll say what? Local maxima. Means in this neighborhood, this is the boss. Over here, this is the weakest point, this is the boss point. Okay. In this neighborhood, local maxima. Over here, again, minima will come. So in this situation, we call it to be local minima, local maxima. Local means what? Neighborhood. So in that particular neighborhood, wherever we are trying to define the minima or maxima, in that neighborhood, what is there? Local minima or local maxima. Condition will be same. Okay. What about absolute minima or absolute maxima? Absolute minima, let's say if I define a function like this. So I have a function going like this, and going like this. Okay. Now check here. There is a maxima here also. We call this as local maxima. This also is. If you take only this point, this will be again local maxima. Okay. And this is what? Local minima. But if you compare the maximum values, this and this, which is greater? This is greater. So I can call for this entire function, this is my absolute maxima or global maxima. Means in the entire function's domain, wherever the function is defined, if my one value is the peak, it's the highest value, I can call that value to be absolute maxima or global maxima. Okay. Local means in that particular neighborhood only. Means whenever we're talking about local maxima, I'll talk about very small, very small region, very small region. Means a small region from here to here. Only this we'll consider. Okay. But for global we'll talk about, or absolute we'll talk about entire domain. For the entire domain of the function, what is the highest value? Then we call it as global maxima. Global maxima. I hope this is clear. Okay. We'll have a question like that where we'll talk about absolute maximum or absolute minimum also. So I hope this is clear. Now we'll learn ways to find it. We'll learn the ways to find the maxima and minima. Okay. So we have two ways to find the maxima and minima, whether local or global. Okay. So we'll stick to local only. Global only at times comes. So what is the difference in global and local? Global or absolute maxima is in the entire domain the highest value or the lowest value. Global means highest value in the entire domain. Global maxima. Global minima means, or local absolute minima means in the entire domain the lowest value. Okay. This is clear. So we'll talk about that whenever they ask in a question. But usually we'll talk about only local maxima and local minima. That will be enough for us. Okay. Chaliye. So to find local maxima, local minima, we have two approaches. One approach is from the first derivative test. Means after finding out only the first derivative, we can identify our local maxima or point of local minima. Okay. All right. Now second approach to solve this maximum minimum problems are second derivative test. Even though name is second derivative test, but this is easier. First derivative test is difficult. I'll show you how. So if you don't mind, I would like to erase this. So it's simple, right? When we can call the maxima to be absolute or global, when it is highest in the entire domain, when it's the lowest in the entire domain, I can call it to be absolute minima. So let me erase this part. I want to show you the first derivative test in this slide only. Okay. Means basically what we're dealing with, methods now. Methods or approach that we have to find what? To learn or to know which point is local maxima or local minima. So they are the same thing, LM. It's okay, na? You understand what I'm saying, right? Local maxima or local minima, which point is that? Okay, chaliye. If you want, I can rewrite it. Why to have a confusion, sir? Why to have a confusion, sir? So methods to find what? Local max or local minima. What is the first method? Method 1 is first derivative test. First derivative test. Okay, bacha. Very simple. What we're gonna do for any given function y equals to fx? What are you gonna do? Y equal to fx. Find the derivative number 1. Okay. So yeah, find the derivative number 1. So if you get, what are you gonna get? F dash of x. F dash of x. Let me say that in this condition, what is the case? I have this as x minus 1 and this is x minus 3. What's my derivative? First derivative is x minus 1 and x minus 3. I'm taking example here, okay? Wanted to explain you the condition. So first step is find the derivative. Then what? Find the critical points. What is the critical point here? My critical points are 1, 3. Again, I'll say find the derivative. This is my step 1. Please see here. Step 1. This is my step 2. Step 2 is what, bacha? Find the critical points. Step 3. Sir, isn't this same as what you are doing for increasing function? Yes, it is same actually. So now what will go? We'll draw it on the number line. So we'll write it as 1 and 3. Okay, 1 and 3. Negative infinity and positive infinity. After 3, what is it? After 3, this is also positive, this is also positive. Please check it. 4 minus 3 is positive, 4 minus 1 is positive. So this is positive. This part is same. Till this part is same as increasing function what we learned or decreasing function what we learned for the previous case. Okay, the interval questions. Okay, between 1 and 3, so 2 I will take. I'll get it as negative. This I'll get positive. So negative. Please understand. If I put 2 here, 2 minus 1 is 1. 2 minus 3 is minus 1. So negative. Now before 1, let's put 0. This will be 0 minus 1, which is, how much is it? 0 minus 1 is minus 1. 0 minus 3 is 0 minus 3 is minus 3. So again, negative into negative will be positive. Now check here. From here only, this is step 3. Now step 4. Step 4. Very important. Trend. This is called as, you'll have to see the trend now. Okay. Now check the trend. Check the trend. If the change is from plus to minus, it means if the sign changes from plus to minus, please understand, plus to minus, it means what? Maxima. It means what? There is a point of maxima at that value. So check here, where is plus to minus? At 1. At 1, I had before 1, what is the condition? Before 1, plus. After 1, minus. Before 1, plus. After 1, minus. So I can say this to be maxima is what? My point 1 is maxima. And what is the other trend? Whenever I have minus 2 plus, check here at 3, minus 2 plus, then what will be? Minima. Please understand this. Please understand this. Draw. So I'll revise all the steps again. First is find the derivative. Second step is find the critical point. Third step is draw it on the number line and identify which is positive, negative and positive conditions. Okay. So find this. This part you have already learned with me today in the session only, how to identify an increasing, decreasing function in the given domain. Okay. Sorry, in the given intervals. So this part till step 3, no problem, sir. We have already learned. Step 4 is the additional part for method 1 to find the maxima and minima point. Yes or no? So how to find maxima point is in this what you call number line. Check the trend. Whenever the sign change across any critical point, I'll repeat, whenever the sign change across any critical point is from plus to minus. Repeat, if you're learning right now, watching this video, repeat after me, plus to minus. Across any critical point, plus to minus, increasing or maximum. Understand this? Not increasing, forgive me. Repeat after me, plus to minus across any critical point, maxima. Point of maxima is when plus to minus across any critical point. If the trend is negative to positive, minus to plus, then what is that point? Local minima. Local minima. Plus to minus maxima, minus to plus minima. But again, isn't this very hectic? Understand this? So far, have a look over here and I'll move to the next slide, which is going to be what? We're working on the method 2 to find maxima, minima. Maxima using first derivative is what? Plus to minus, maxima the trend, minus to plus, minima the trend at any critical point. Moving on to the next slide. Okay. Next is what? Second derivative test. second derivative test. Sir, you said first derivative test will be, the name suggests first derivative, right? Simpler, right? So for that reason only, because it is complicated to find all the numbers, it takes time to find all the critical points, then to find what the trend also, identify, put the values. Let's say I have 3 numbers, so I'll put at 1, 3 and 5, whatever it is. 4 numbers, 4 critical points are there. Put for all these values. So again, to find the nature trend, negative to positive, positive to negative, mistakes can also happen and you will take more time to solve it. Then comes the helper boy. What is the helper boy? It will help you to solve any question in seconds. Okay, what is it? Second derivative test. How will you do it? As the name suggests, first find the step 1. Step 1 remains unchanged. What is it? Bhaiya, nikalo derivative. Find out derivative, sir. Step 2. Step 2 will be what, bacha? What? Critical points, sir. Critical points. How do you find critical points, sir? I forgot. No problem. Put y dash equals to 0, bacha. Y dash equals to 0. Find all the x value where the function is, this value is becoming 0. So critical point you can find from there. Step 3. Step 3 is what? Find the second derivative. What is it? Find second derivative. So you already find the first derivative over here, no? Differentiate it again. Differentiate this part again, you'll get the second derivative. Okay? Chaliye. Step 4. So step 4, I'll write it over here on this side. See this. Step 4. The last step for this problem. Step 4. So step 3 till step 3 remains same. There's no number line here. So simply find the y double dash value. Let's say I get 2 critical points here. I get it as A and B. 2 critical points I get here, A and B. Okay. So find the y double dash value. Once you found the derivative, no, substitute A in the second derivative. Substitute A in the second derivative. If it is more than 0, what is it? Minima. Ulta? Yes, sir, ulta. If the second derivative is more than 0, then minima. Second condition. If the second derivative is, let's say, less than 0, then what? Maxima. Condition 1, condition 2. As simple as that. Very simple. Second derivative value you already found in the step 3. Okay. What are you going to do? Substitute the critical points individually. If the critical points is giving you positive value, then minima. Negative value, then maxima. This is simple. First derivative you understood. Second derivative also is you understood. Okay. This is preferred actually. I would suggest use this approach more in the question. If you think that approach is simpler for you, if you think that will be faster for you, use that approach. But I would suggest this will be faster, and this over here you'll make less mistakes. Chances are of making less mistakes. So use this method to find the local maxima and minima. Now moving on to the problem, sir. Okay. Question number 14. Question number 14. Prove that the following function do not have maxima or minimum value. चलिए कर लेते हैं. First one is what, बच्चा? First one is, see here, first one is y equal to ex. Y equal to ex. Okay. To find maximum minimum, what we do? Y dash we find, e power x will remain as it is. Okay. We also find y double dash. How much is that? How much is that? E power x. Now after finding this, correct now, because derivative of e power x will remain as it is only, no? Some people will say will have an argument saying that, sir, you only said few minutes back that e power x will be always positive. Since this is positive, sir, point of minima. Sir, always positive, sir. Point of minima or minima. Okay. What did I say to you first? What did I say to you first? Do not look for that. Do not conclude directly. First of all, you have to find the critical points. Find the critical points. Don't look the functions over here. Okay. Do not look the functions sign over here. Look at the critical point. If you look at the critical point, so what is going to be? E power x equal to 0. That's how you find the critical point. Is exponential function ever 0? Can you make exponential function 0? No, sir. E power x can never be 0. E power x can never be 0. In that situation, because e is a number, right? Power anything will be never making it 0. So again, you cannot have maxima, no, minima, also no. because you don't have any critical point only. Where will you find the maximum minima? Okay, there is no critical point. Next one, second one. Okay, second one. Okay, second one is what? Again same thing, log x. Y equals to log x. Tell me, differentiation. Y dash is what? 1 upon x. Let's forget about second derivative right now. Find the critical point. Equal to 0. Can 1 by x be ever equal to 0? Tell me. Can this be ever equal to 0? Not possible, sir. Not possible. Okay. It means what? It means what? Again, there is no maxima, no minima. Again, no maxima, no minima. Maxima also no, and minima also no. No point of maxima, no point of minima. Next one, x cube plus x square plus x plus 1. Let's check this. Third one, x cube plus, sorry, check here, right here, y equals to x cube plus x square plus x plus 1. Is it right? Yes. Derivative, what will this be derivative? What will this give me as derivative? 3x square plus 2x plus 1. Am I right? Am I right? Okay. Now check here please. If I take this to be derivative, how will I take this? So if I write it here as 3x square plus 2x, okay. I have to find what? Critical point, no? Forgive me. Critical point, right? What is equal to 0? What is this going to be, bacha? This is what, bacha? A quadratic equation. How we find quadratic equation? X equals to minus b plus minus root under b square minus 4ac upon 2a. Right? Okay. Now what are we going to put? Values of p. Minus of 2. B is 2. Minus of 2. Plus minus. B square is how much? 4. And 4ac will be what? Minus 4 times of a is 3, c is 1 upon 2 of a, so 6. 2 of 3 is 6. How much is this coming as? Minus 2 plus minus 4 minus 12. How much is that? Minus 10. 6. Is this a real number? Not real. Please check. Number minus 2 is real, but root of minus 10, imaginary number, complex number will come. So this is x is coming as, imaginary number. Then how will you plot on the number line, on the real number line? So if the x is not existing, okay, x is not existing, okay, it means what? It means what? No maxima, minima. No maxima, no minima. So why, sir? There is no value of x. There is no critical point only. Then how will you find the maxima, minima? Okay, not existing in nature. Moving on. So for all the three functions, we proved that these functions are not having any critical points or any maxima or minima. I hope this is clear. Okay, moving on. Find all the points of local maxima, local minima for this function. Very good. Let's see. We'll apply our entire approach in this. Let's see. First thing is what? Derivative. Y equals to what is given? X cube minus 3x plus 3. Apply this. Y dash will be what, bacha? 3x square minus 3. Am I right? Yes. Find the critical points. I get what? Y dash equals to 0. So 3x square minus 3 equal to 0. Yes, 3x square, right? This is 3x square minus 3 equal to 0. Okay. Take 3 common. I get x square minus 1 equal to 0. Yes. What is it going to be? 3 times of x minus 1, x plus 1 equal to 0. Yes. A square minus b square formula. A minus b, a plus b. Then put this and get me the critical value. From the first bracket I'll get 1, from here I'll get minus 1. Two values I'll get plus 1 and minus 1. Critical values are plus 1 and minus 1. Okay. Alright, x is plus 1, x is minus 1. Okay. Now to find what? What is the next step? Second derivative. Find out y double dash. Y double dash will be what, bacha? Differentiation of first derivative is how much? 3x square minus 3. How much is that going to be? 6x minus 0. How much is that? Simply 6x. I have to find point of local maxima, local minima. So I have two critical points. Find it. So y double dash. You have to only find the points of. You don't have to find the maximum minimum value. So y double dash equals to of 1 equals to 6 times of 1 How much is that? 6, so less than 0. So what is it? 1 is what? Point of minima. See? Not less than, greater than 0, no? 6 times of 1 is 6, greater than 0. So point of minima. Next condition is what? Next condition is for the other critical point, which is -1. 6 times of -1, how much is that? 6x is there, right? So 6 times of -1, it will be -6, so less than 0. So -1 is what? Point of maxima. Simple enough. Simple enough. -1 is point of maxima and 1 is point of minima. Answer is there. All points, so we have got only 2 critical points. For both the critical points, we found the second derivative, put the x as 1 and -1, one came as positive, so minima, other came as negative, so maxima. Simple enough. Moving on, chaliye. Question number 16, find the, yes, that's what we're talking about, right? Absolute maximum value and absolute or global minimum value, whatever you call, absolute or global, same thing, okay? Of the following functions in the given intervals. Great, given intervals. Now tell me, what you used to do? Okay, first, if the interval was not given, we used to find the critical points. So we know that we will check for maximum minima at only critical points. Okay, but apart from critical points, we have other defined points also. For example, let me check the first one. Let me see the first one. Okay, so first one, if you see here, y equals to what? X cube is there. Y equal to x cube is there. Okay, so if I do the y derivative, I'll get what? 3x square. What is the condition to find critical point? Put it equal to 0. I get x as 0. So I have only one critical point, which means minima or maxima, whatever it is, will exist at x equal to 0 only. But apart from this, we also have two defined values, -2 and 2. Please check. X equals to -2 and 2 are also there, right? It means even this will have some value of y. Please check y value at this point. Y of -2 will be what, bacha? Tell me, -2 ka cube, how much is that? -8, okay? And y at, what is 2? Check what is value of y at 2? +8, so +8. Check here, y at -2 is -8, y at 2 is +8. So I also have these existing values. Since the interval is closed, if it was open, then what will happen? I don't have to find this. Even if they said global maxima, global minima, we don't care about this. Why, sir? If this was open, if this was closed, if this was open interval, we cannot find the value, right? So we'll not bother about this. We'll only find the critical point and we'll say that as our absolute or local. You can say anything from there, okay? No condition, no problem. When this was open, means this is meaningless. If I keep it open, right, then this condition is meaningless, okay? But since it is closed, then I have to find the value at that function. We have to find the value of the function at those 2 points also. Now check whether this is point of minima or maxima. What I'm going to do? Check here. I'll do the y derivative. Double derivative, sorry. It will become what? 6x again. 6x. At x equals to 0. What I'm going to get? It will be 0, right? So I cannot have this. I don't have to figure it out from here. I can see the trend from here only. Or directly I can find it. No. Y of 0. How much is that? Simply 0, sir. Simply 0. Y is also 0, no? This is the point, okay? Now please check here. This is the point of inflection actually. Doesn't matter. So what is my maximum value here? This is the point of inflection, okay? Means there is no change over here. There is no change. This is simply 0. Because y at 0 is 0. Derivative is also 0. Double derivative is also 0 only, okay? So maximum value is what we're telling you. Maxima is 8, okay? And minima is what? -8. What is the absolute maxima? And absolute minima is like this, 8 and -8. Even though 0 was also minimum value, but we can't take that. We can take only -8 and 8, okay? Question number 2, sin x plus cos x. The function is given as sin x plus cos x in 0 to pi. You'll see this. Good question. Question number part 2, y equals to sin x plus cos x in the domain 0 to pi. In the domain 0 to pi. Both closed means there's a meaning to it. If this is open, then no meaning, meaningless condition. But there's a closed interval, means we have to use the end points also. So understand this. For absolute minima maxima, you have to check for all the point in the function where you can find the value. We cannot take any point between 0 and pi, right? It's not defined one point, okay? So but last 2 points are defined. So we can take those 2 points as my endpoints and find the value of the function at those 2 points also. Okay, so we'll see now. So first find what? Derivative. Find derivative now. Y dash, how much is that? Tell me. Cos x. This is minus sin x. Put it equal to 0, please. Why 0, sir? To find the critical point. How much that will be get? How much that will give me? Cos x equals to sin x. What is this going to be? When is this possible? Tell me. When is this possible, sir? I can do cos x by sin by cos as tan. Okay, then when is tan x 1? Or I can understand from here also. When is cos x equal to sin x? Okay, tell me. Pi by 4. At pi by 4. Sin x is also 1 by root 2. Cos x is also 1 by root 2. So at pi by 4 it is the condition. So I get one of the value. The critical point is what? Pi by 4. Only one I get. But I also have two more values. What is it? 0 and pi. 0 and pi also are there. What are these two values? My endpoints. My endpoints. I have to find this function value at this point also. Okay. So quickly find it. Let's quickly find it. Let's check here. I can find y double dash also. Okay. But don't have to, because we have the point. We have the function. Let's substitute it in this also only directly. Y at what point? Let me find it as 0 first. Sin 0 will be what, bacha? 0. Sin 0, please check. Sin 0 is 0 and cos 0 1. So 1. I am putting 0 in place of x. So sin 0 is 0, cos 0 is 1. Now I am putting pi. Please check here. My pi. Sin pi is what? Again 0. Sin pi is 0 and cos pi is what? Minus 1. What is it? Minus 1. So our answer is minus 1 and 1. Is it? Let's check. Y value at pi by 4. Sin pi will be 1 by root 2. This will be, cos pi will also be 1 by root 2. What is the sum? 2 by root 2. How much is that? Simply root 2. How much is that? 1.414. 1.414. So what is my maxima? What about maxima? Absolute maxima is root 2. And what is my absolute minima? Minus 1. These are my answers. I hope you get this. Okay. Absolute maxima is root 2. Absolute minima is minus 1. Simple. Yes. Okay. Let's move on. Question number 17. Find the maximum minimum value for this function x plus sin 2x 0 to 2 pi. Okay. Excellent problem, bacha. Excellent question. You'll see how. You'll see why. Okay. So first of all, function is given as y equals to, you can write like this, x plus sin 2x. Yes or no? Yes. Find the y dash first. What is y dash going to be? 1 plus cos 2x times what? 2. Correct, right? Sin 2x differentiation is cos 2x. Differentiation of 2x is what? 2. What is the condition? We put it equal to 0. 1 plus 2 cos 2x. Bring this one here. Minus 1 upon 2 equals to simply cos 2x. How, sir? 1 comes here negative. 2 is in multiplication, comes in denominator. Okay. When is cos minus 1 by 2? Tell me. When is cos minus 1 by 2? When 2x will be what? When 2x will be what? Pi minus pi by 3. Understand this? So 2 pi by 3. So why are you writing like this? Second quadrant. Because in first quadrant you will not have negative minus 1 by 2. So at pi by 3 it is 1 by 2. We know that. At 60 degree. Understand it. At 60 degree what is it? Cos. Cos is negative. But 60 is positive 1 by 2. At 60 degree cos is 1 by 2. Okay. So at 60 degree cos is 1 by 2. But it is positive. But I want a minus 1 by 2. Means pi minus pi by 3 I will take. So what is this value? 2 pi by 3. Okay. 2 pi by 3. Okay. Now this is given for which condition? X. So when x is what? Lying between 0 to 2 pi. Where is my 2x lying between? Tell me. What's my domain for 2x? What is it? Simply 0 to 4 pi. Simply 0 to 4 pi. Yes or no? Yes, sir. Okay. So how many points will exist as such? Tell me. So the 2x value can be, first of all, 2 pi by 3. 2 pi by 3. Yes. Or it can what be? What can it be? It can be, again, next one will be second quadrant, right? So next one will be what? When is cos negative? Please check here. Cos is negative in second quadrant and third quadrant. So what I'm going to do? Pi plus pi by 3, how much is that? 4 pi by 3. Are you able to understand this? Pi plus pi by 3, why I'm taking this? Please check. If I take cos of pi plus pi by 3, please check here. At pi, cos will remain cos only. Cos will remain cos only. At pi by 3, it will become what? Please check here. Cos pi plus pi by 3 is what? Cos pi by 3. Why, sir? At pi, it will not change. What is this quadrant? It's third quadrant, so negative. What is cos pi by 3? 1 by 2. So what is the answer? Minus 1 by 2. Isn't that what we're looking for? We're looking for minus 1 by 2 only. This is not looking like minus 1 by 2. Let me rewrite this as minus 1 by 2. Minus 1 by 2. Okay. So cos will again, first it was negative at 2 pi by 3. Okay. Then again it will negative at pi plus pi by 3. How much is that? Check here. 3 pi plus pi. So 4 pi by 3. Hope this is clear. Okay. I hope this is clear. Now, so any other point? Please check. This is for what? I have went once here and once here. So 0 to 2 pi. Once we have gone. But is it the domain? No. 0 to 4 pi. We have to go twice now. So first we went to what? Check here. We went to 0 to 2 pi. Means first we went in second quadrant. So I got it as 2 pi by 3. Third quadrant we got it as 4 pi by 3. Is it is? No. We have to again go. First cycle complete. We have to go again. Why? Because this, what is the domain? 4 pi. Domain is 4 pi. So let's check the third one. Let's check the third one. How much is that? Third one is what, bacha? Tell me. Third one will be 2 pi. So basically it has to come here again. Because any angle in first quadrant will be what? Positive. I want in this quadrant. So what will this be? So this is 2 pi. This will become what? 3 pi, na? I'm taking my second round. Take here. First it was 0, then pi. Then I came here, becomes 2 pi. I'm going back here. So 3 pi, right? What I'm going to do again? 3 pi minus pi, right? Apply cos with it. Cos at 3 pi will be cos only. Angle is pi by 3. Which quadrant? Quadrant is second, so negative. What is the answer again? Minus 1 by 2. That's what we're looking for. Yes. What's my angle? 3 pi into 3. How much is that? 9 pi. 9 pi minus pi will be 8 pi by 3. 8 pi by 3. I hope you understand this. 3 times of 3 pi, 9 pi minus pi, 8 pi by 3. I'm taking my time here because I know for sure students have this confusion. Sir, if I write the all angles, no, 2 pi, 4 pi, 8 pi, and what? Next one will be 12 pi. How much is that? Please check. Not 12 pi. We'll see. 3 times will take 4. So 4 pi, 6 pi plus, 10 pi, all right. Next will be 10 pi by 3. Okay, if I write it like this, you will not be confused, you will not be able to recollect or connect with me in this question. So that's why I'm doing for all the conditions. What is my domain? 0 to 2 pi, 0 to 4 pi. First I did for 0 to 2 pi, I got two answers, 2 pi by 3, 4 pi by 3. Now I'm going for the second cycle. So this is over, I have one more value to go. Check here. When will this come? Next tell me. I hope you can get it from here directly now. So again, it will be minus 1 by 2. When the third quadrant is coming, this is going to be what? 3 pi plus pi by 3. Please check here. When cos is there. Okay, cos at 3 pi will be what? Cos only, and this will be simply pi by 3, third quadrant, so negative. What is this answer? Again minus 1 by 2. What is this angle? 3 pi plus pi by 3. 3 times of 3 pi is 9 pi. 9 pi plus pi is how much? 10 pi by 3. So my points of 2x will be, my x value, my 2x are what? 2 pi by 3, 4 pi by 3. What is this? 8 pi by 3 and 10 pi by 3, sir. 10 pi by 3, sir. Yes or no? So if this is my 2x value, what is my x value? Tell me. What is my x value? My x value will be what? First one, pi by 3. This will be what? 2 pi by 3. This will be what? 4 pi by 3. This will be what? 5 pi by 3. 5 pi by 3. Why I am finding for x? Because of substitute in the function also. Okay. So this value is known. Let me erase this extra part. Not part of the solution. This is just to explain you how this is coming. Okay. This also is not part of the solution. Okay. Just to explain you or recollect with what? Recollect with your quadrant rule. Okay. Now I got the derivative. So I got my critical points. For 2x I got my critical points. Okay. This I have written for both 2x and x. Okay. Now I want to find what? Maximum minimum value. Okay. So how I'm gonna deal with it? Please check. Please check. So I'll be what? Tell me. So let me find it for y equals to first what? Pi by 3. Tell me here what is the value. X will be as it is. I have found a critical point. We'll see the value of which is critical, which is maxima, which is minima from the value only. Okay, we don't have to find the second derivative. We can directly find from the function's value only. So it'll be what? Tell me here. So pi by 3 will come as it is. If you want, I can write the function once. I can write a heading as a function only. What is the function? Function is y equals to x plus sine 2x. X plus sine 2x. So what is my y at pi by 3? Tell me. So pi plus sine 2 pi by 3. 2 pi by 3. Yes or no? Yes. Where is this angle? Where is this angle? Second quadrant. Okay. Second quadrant, what is this value going to be? Tell me here. Pi plus simply root 3 by 2. Not pi. Pi by 3, right? Please check here. Because if I'm writing here pi by 3, it becomes 2 pi by 3. 2 pi by 3 was in the second quadrant. Second quadrant sign is positive. And what is that pi by 3? It's root 3 by 2. Whenever cos is 1 by 2, sine is root 3 by 2. We're going to use this relation. Very simple. Cos is 1 by 2, right? Remember? It was always 1 by 2. I did for all these cases. Excuse me. I did for all these cases. It is coming every time 1 by 2, 1 by 2. Negative, it's okay. Okay, no problem. Okay. But what my condition is, whenever the cos was 1 by 2, sine will be what? Root 3 by 2. No problem. So what we get? Pi by 3 plus root 3 by 2 for the first value. For the second one, what I'm going to get? Tell me here. I will have 2 pi by 3. My second x value, please check here. 2 pi by 3 from here. 2x was this condition. 2 pi by 3, 4 pi by 3, 8 pi by 3, 10 pi by 3. I'll divide everything by 2, no? So it will become pi by 3. 4 pi by 3 will become 2 pi by 3. Divide this also by 2. 8 pi by 2 will become 4 pi by 3. 10 pi by 3 will be divided by 2. 5 pi by 3. So next value is 2 pi by 3. So put it here. What I'm going to get? 2 pi by 3 plus sine of what? 2x. It means 4 pi by 3. Which quadrant is this angle in? Third quadrant. Third quadrant sine is positive or negative? Negative. This is third quadrant angle. Sine is negative. What is it going to be? 2 pi by 3. What is it? Minus root 3 by 2. Okay. Alright. Next is what? Y at what? 4 pi by 3. 4 pi by 3. 4 pi by 3. Check here again. I'll write here 4 pi by 3 plus sine of, what will this be? 8 pi by 3. It will be 8 pi by 3. Yes or no? Yes, sir. Simply write it as 4 pi by 3. Where is this angle 8 pi by 3? It's going to be in second quadrant again. So plus root 3 by 2. Think about it. 0, pi, 2 pi, 3 pi. Is this angle 8 pi by 3 less than 3 pi or more than 3 pi? If it was 9 pi by 3, no, it will be 3 pi. So 8 pi by 3 is less than 9 pi. Which quadrant? Second quadrant only, sir. Okay. If you're not getting the angles of how I'm taking it, no. See, this was 4 pi by 3. So more than pi. Because 3 pi by 3 is pi. 4 pi by 3 is more than pi. So I took it as second quadrant. I took it as third quadrant. I wrote it as negative. Over here, 8 pi by 3 is less than 9 pi by 3, which is 3 pi. So second quadrant, I wrote it as positive. Please see this now. Okay. Same way I'm going to do with the last value. How much is that, bacha? Y at 5 pi by 3. This will be what, bacha? 5 pi by 3 plus sine of 10 pi by 3. Tell me which value. 9 pi by 3 was in which quadrant? Was in 9 pi by 3 was 3 pi. Okay. So plus anything will be third quadrant. What will this be? Tell me. 5 pi by 3 plus, what is it? Root 3 by 2. Root 3 by 2. What is my maxima then? Maximas, okay, and minimas, okay. So this is my maxima, global maxima. Next, what is it? Global minima will be what? This is, I think, minima. How much is that? 1.14. And how much is this value? 3.14. This is going to be what? Simply 1.2 point something minus 1.4. Okay. So simplify this. Okay. So you have to arrange this and give me the answer. Homework. Comment now. Okay. What is the comment? So at pi by 3, at 2 pi by 3, at 4 pi by 3, and at 5 pi by 3, which is maxima, minima and maxima. Comment below. Okay, comment your answers. I've done everything for you. Just put it there, find the calculation, not the calculation, approximately value, and check which is highest. So maxima, maxima, minima, minima. Okay, chaliye. If you don't want to find that, find the derivative or second derivative also. From there also you'll get the trend. Okay, chaliye, आगे बढ़ते हैं. Moving on, I hope this is clear. This is visible, right? Visible, right? Okay, all right, sir. Okay, find the two positive numbers x and y such that their sum is 35 and the product is xy. This will be homework. My homeworks are calculative, okay? So I'll give you all the hints, but I'll give it as homework. How will this look like? Please check. Okay, so they are saying that x times of y will be 35. Okay, so what is going to be my x value? No, sum is 35, right? Sum is 35, no? Sum is 35, not x plus y. This is not x times of y, x plus y is 35. Please check here. X plus y is 35. What is my x value then? 35 minus y. Okay. What is the question given here? X square y power 5. Take this as p. P equals to what? 35 minus y the whole square. Okay. Apply the product rule here, dp by dy, you can find it out. Well, 2 times of 35 minus y, keep it as it is, y power 5 you can keep as it is. Okay, now again what? Keep this part as it is, and this will be what? Y power 4. Okay, take y power 4 common, not y power 4, I can take more thing common, so let me just take it for you. I'll take 35 minus y times y power 4 common. What I'm going to get? Check here. I'll get here 2y minus, okay, there's a minus sign over here, because why, sir? If I'm differentiating this part, I'll get 2 times of 35 minus y, but I'll have to differentiate minus y also, no? So there will be a minus sign here. I forgot to mention. See, it is minus y. Chain rule will be applied. Chain rule will be minus y will be what? Minus 1. So minus 2 will be coming. Okay, plus. Please do this differentiation. Perform this differentiation over here. Okay. I've taken this common. What is it left now? 35 minus y. Okay. Simplify this. Get your dp by dy. This is going to be a dp by dy or y dash. Differentiate again. Get second derivative. Find the nature. Find the critical points from here. Okay. I'll tell you the answer. X will come as, I think, 10, 25. This is your answer. This is your answer. Comment that. Comment. Got it right, sir. GIR. Got it? Right. Got it right, sir. Okay. Simple problem. Calculative. There is a lot of calculation here. You have to multiply here. Okay. So calculation is there, but not much difficult. Okay. Solve it. Give me the answer. Comment below for your answer. चलिए आगे बढ़ते हैं. If length of 3 sides of a trapezium, very good question. Okay. Very good question. Other than base are equal to 10 centimeter. Means what? Check here. A trapezium is like this. They're saying that this is 10, this is 10, and this is also 10. Find the area when it is maximum. Okay. So if I take this, this is going to be 10. I want to take this length to be x and this also to be x. Okay. What's going to be this value now? Tell here. Isosceles trapezium, no? 90 degree, x is there. This is also x. This is going to be root of 100 minus x square. Okay. So let me just write it over here, not right there. I'll take this to be height. Okay. So my height will be what, bacha? Root of 10 square, which is what going to be 100 minus x square. This is my this. What is the formula? What is the formula for the area of trapezium? Area will be what? 1 by 2, sum of the parallel sides. So 10 plus 2x, correct, na? This is 10 and this is 10 plus 2x, okay? Times of height, yes or no? What is my area then? Tell me here. 1 by 2 times of 20 plus 2x or not? Height is what? Yes or no? Yes. How much is this? Please take here. We'll cancel this. Okay, what am I going to get? 10 plus x times of root of 100 minus x square. This is my area. Okay, I have to find the derivative of this. Find the derivative of this. Can I find it over here? Let me just do it in the next step. Okay. So what is my area? I got it as 10 plus x times of root of 100 minus x square. Yes or no? Yes, 100 minus x square. Find the area derivative. Why I'm doing this? To find the critical point. I'll take the derivative of this part. It will become what? Simply 10 will be 0. This will be 1. This will remain as it is. 100 minus x square. I'll do a plus sign. I'll keep 10 plus x as it is. And this will be what? 1 by 2 times of 100 minus x square in the denominator. Because this is power 1 by 2. Do the differentiation here. It will come minus 1 by 2. So in the denominator. And what is this going to be? Minus 2x. So let's cancel this and this. Okay. 2 and 2. Okay. I'm doing the differentiation faster. Please do it from your side if you are confused. If you're confused with the differentiation, do it from your side. Minus sign and this plus will become minus. Okay. This will be what? 10 plus x times of x upon. Okay. What is the LCM? Please tell me. 100 minus x square. So this will become simply 100 minus x square. Okay. Minus what? Minus 10x. And plus, minus x square. Correct, right? Right? Minus 10x minus x square. How much I'm getting? Please check. I'm getting this as minus 2x square minus 10x and plus 100. Okay? Divided by the same root. 100 minus x square. Okay? Now to find the critical value, please check here. So this is basically what my a dash. What is a dash? Minus 2x square minus 10x, okay, and plus 100 upon this whole thing equal to 0 is there. I can multiply it on this side. I'll get what? This condition. Minus 2x square minus 10x plus 100 equal to 0. Okay, solve for this. Take the 2 common. What I'm going to get? X square. I'm taking minus 2 common. X square plus 5x minus what is it? 50. I'm taking what? 2 common only, right? So 50, no? Minus 50 equal to 0. Okay. So cancel this. I'll get what? X square plus 5x minus 50 equal to 0. What is the condition now? X square plus 5x minus, forgive me, plus 10x minus 5x, no? 10 times of 5 is 50. So plus 10x minus 5x minus 50 equals to 0. What is the condition now? X plus 10 times of x minus 5. Please check here. Please check here. Please check. X plus 10, x minus 5. Okay. If you put it here, if you put x equals to 0, this thing will become what? I'll get a condition as x equals to minus 10 and plus 5. I can't take minus 10. The length cannot be negative. This length cannot be negative. What is my answer? 5 only. My answer is 5. This is my only critical point. Okay. Okay. Now, how can I check the trend? How can I check the trend? From here I can check the trend, sir. Please check. Only 5 I can draw. After 5, please check. After 5. After 5, what is happening, bacha? Please check here after 5. So, why I am not doing the second order derivative test? I have to find point of maxima, right? Why I am not doing second order derivative test? If you differentiate this, it will become very, very complicated. Yes or no? Please check. I will take more time. So, I can check from here only. I can check from here only. Please check. So, after 5, what is happening? After 5, if you take a 6 number, if you take a number 6, 2 times of, minus 2 times of 6 square is what? Please check. I am taking 6 here. 6 square will be 36. Minus 2 times of 36, minus 72, minus 60. How much is that? More than 100? So, negative. I'll explain again. I am taking after 5, 6. 6 square will be 36 times minus 2, minus 72 times 6 times of 10, minus 60. How much is that? Minus 132. Okay. Which is more than 100. So, negative. Numerator is negative. This is positive. Okay. Means negative. What about this part? I take 4. Before 5, I take it as 4. 4 square, 16. 16 times 2, minus 32. 4 times of 10, minus 40. How much is that? Minus 40, minus 32, minus 72, which is less than 100. So, again, positive. See the trend now. Plus to minus. Okay. I said no. For the first derivative test, we have to check the trend. What's the trend now? Please, bacha, check. Plus 2, minus sir. Plus 2, minus sir. Plus 2, minus sir. Plus 2 minus means what? Plus 2 minus means maxima. What is plus 2 minus? Y derivative. The derivative is plus 2 minus. Okay. So, maxima. At what point? X equals to 5. I got the value over here. 5 put here. A as 5. So, it will be 15. Okay. It will be 100 minus 25. So, 75. I can take this as 25, so I'll take 15. This will be 25 times of 3, so 15. 25 will come out as 5. 75 root 3. Centimeter, meter something, centimeter is there. So area is this. This is my area. Okay. It was given that trapezium is having non-parallel sides also as 10 and one of the parallel side as 10. I got it as x and x for the extra part. Got the expression in terms of, I got this height in terms of x from the right angle triangle. Got the area expression like this. This is my area expression. Took the derivative of this. Okay. Found the first derivative. From here found the critical point as minus 10 and 5. Length cannot be negative, so I took only 5. Taking 5, I got the trend from plus to minus, means maxima. Remember, plus to minus means maxima. Minus to plus means minima for the first derivative test. For the second derivative test, what happens? Greater than 0, minima. Less than 0, maxima. So sometimes what happens is, first derivative test becomes easier. First derivative test becomes easier to solve. So I took the first derivative test, plus to minus maxima. Check here. So I got the answer as 75 root 3 centimeter square. Question number 20. Okay. So that all the rectangles inscribed in a given fixed circle, the square has the maximum area. Now we have to prove that for a circle, okay, if I have a rectangle drawn here, we have to prove what? We have to prove what? That this side, if this is x, this is y, okay, and this is, let's say, r and r, okay, the radius of the circle, r and r, okay, then they have to prove what? That this condition, in this condition, what is happening? This rectangle ABCD is a square. Basically, you have to prove x equal to y. You have to prove x equals to y, sir. Okay. How can they prove it? They are saying that it's maximum. Means if I can maximize the area of, the rectangle ABCD, if I'm maximizing, they are saying that maximum. So maximum will occur when x is equal to y. That's what they are saying. Okay. So we'll prove that. So how will I write area? So area will be written as, let me write it here. Area of ABCD will be what, bacha? X times of y. Okay. I can write y as, please check here. I can write y as, or y square as 2r the whole square minus x square or not. From right angle triangle ABC, 2r the whole square minus x square. How much is that? 4r square minus x square. Yes or no? Please check. 4r square minus x square. Yes or no? This is my y. So what is my only y value? My y value will be root of 4r square minus x square. Now what is the area? Area A will be given by x times of y. What is my y? 4r square minus x square. Okay. Alright. Let me square this up. If I square both sides, I'll write a square as some other variable, let's say s. Okay. Some other variable s. Okay. This will become x square. This will become what? The root and square will cancel each other. This is it. 4r square minus x square. Please check this. Please check this. Okay. So I get this as 4r square minus x square. Okay. So now if this a square is maximum, then a will be maximum. So instead of maximizing a, I am maximizing what? I am maximizing a square, which is nothing but s in this case. So if I maximize s, it means if I am taking derivative of s, okay, if I maximize after taking derivative and doing all the process, s as maximum, I'll get a also as maximum. Why I'm taking s? Because it becomes easier over here. Please check. What I'm going to get here? I'll get it as 4r square x square minus x power 4. Yes or no? This is my s. I'm taking this derivative with x. What is this going to be? 8r square x, right? This will be what? 4x cube. 4x cube. Please check here. 4 times of, I'm taking derivative of x, right? So 4 times 2 is x. R square will remain as it is, and x minus 4x cube. Put this equal to 0, bacha. Keep this equal to 0. What I'm going to get? So I'll get here, I can take what common. So let me just write it here only without taking common. X equals to 4x cube. 4x cube. Okay. So next step I have to do. I'm getting here as 8r square x equals to 4x cube. Okay, 4x cube. So let's divide everything by, let's bring this x over here. I get 8r square equals to 4x cube by x or not? Yes. And bring this 4 over here, I get what? 2. What I'm getting? 2r square equals to what? X square. So what is my x equals to? Root 2r. Yes or no? Please check. X equals to root 2r. Okay, because r square will be coming as r and root 2 will be like this. Now this is my point of, critical point is only one, x equals to root 2r. I have to maximize it. What I'm going to do? Second derivative. What is first derivative? 8r square x minus 4x cube. So my ds by dx was 8r square x minus 4x cube. Take the second derivative. d square x upon dx square. How much is that? Please check. How much is that? This will be what, bacha? Simply 8r square minus 12x cube or not? 12x cube or not? Yes. Put here in place of x this value. I'll get what value? 8r square minus 12. Okay, not x cube, x square. Okay. I've taken the differentiation, no? I've taken the differentiation. So 3 will come in front. This will become x square, right? So 12 times of x square will be what, bacha? Tell me. Root 2r the whole square. Correct? So this will be what, bacha? Tell me. 8r square, okay, minus 24r square or not? Root 2 square is 2, r will be what? R square. R will be r square. So will become what? It will become minus 16 r square. Check here. R square is positive, minus 16 is negative. It means I'm getting what? d square s upon dx square at what value? When x is equals to root 2r is coming as negative. Means what exists? Point of maxima exist. Means I've taken the condition now. I started from the rectangle, I used the maximum condition, I got a critical point. What is the critical point? This critical point is giving me maxima, sir. Giving me maxima. It means x equals to root 2r is maxima. What is the y value? Tell me. My y value was a square of, since this s is maximized, means area is maximized because this is nothing but square of the a. If a is maximum, a square is also maximum. Same way, if s is maximum, root of s, which is nothing but a, is also maximum. Okay. What was this? Please check here. 4r square minus x square. So 4r square minus x square. How much is that? Please check. 4r square minus x, how much is that? Root 2r the whole square. Root 2r the whole square. How much is that? Please check. So this will be 4r square minus 2r square. How much is that? 2r square. How much is that? Root 2r. So what I have achieved? What I have achieved over here? Please check. I got x value as root 2r and my value, y value is also root 2r. It means I'm getting x. Okay. I'm getting x and y equal. I'm getting x equals to y equals to root 2r, sir. Root 2r. Now what is happening here? Please check what is happening here. When can we say sides are equal? If it is square. So when I took the maximum condition, what I've reached here? I have reached that x and y are equal. It means what? ABCD is a square, bacha. Okay. So I hope this is clear. I took it to be rectangle. Side was xy and the diameter was 2r. I got y in terms of r and x. Okay. To the differentiation, use the formula for x and y. Okay. Square it up to remove the square root so the differentiation is easy. Instead of maximizing a, I maximize a square. Okay. Same thing. Okay. When a is maximum, a square is also maximum. Okay. So I maximize s. I took a square as s. Maximize s as by finding derivative first and second. Got the critical point to be root 2r. Check for the maxima. It was coming negative, so maxima only. From that condition, I use y value. I would use x value. In the y value, got x also and y also same. Root 2r, root 2r. It means it is the condition when, hope this is visible, when it is going to be for the maximum rectangles area, it has to be a square, sir. Square, sir. Now, the minimum value of mod x. Arey, some MCQs. I explained you right. This one. Mod x is like this. Minimum value is what? At this point, how much is that? 0. Answer is A 0. Answer is A 0. Moving on. Maximum value of fx. Okay. Please check y equals to this bracket is what? It can be either 0 or square or not. It can be either 0 or positive or not. This can be either 0 or positive. Yes or no? Square will be either 0 or positive. Okay. If I multiply with a negative number over here, it will be either 0 or negative, right? Then it will become what? Either 0 or negative. Why, sir? Positive multiplied with negative will become 0 or negative. So maximum value will be when this is 0. Understand this? Y maximum will be when this is 0 plus 10. How much is that? 10. Option number B. Sir, why this is when 0 it is maximum? Because if I take any other number than 0, it will be what? Negative, no? So minus 1, minus 2, whatever it is. For any value, when x is, let's say, I'll take x as 2. 2 minus 1 is what? 1. Take x as 2. 2 minus 1 is 1. 1 square is 1. Multiply with minus sign, minus 1. 10 plus minus 1 is plus 9. So less than 10 or not? Yes. Let's take minus 2 value. Minus 2 minus 1, how much is that? Minus 3. Minus 3 square is 9. Minus sign is there. Minus 9 plus 10, how much is that? 1. Whether you take negative or positive x, whatever happens, it will be less than 10 except for x equals to 1. When x is 1, this will become 0, and then the value of the function will become maximum, which is going to be 10. Option number B. Okay. In second derivative test, first of all, correct, f dash of c has to be 0. Okay. And double derivative is also greater than 0. What is this? Without a problem, local minima. Okay. I said local minima and ticked for local maximum. So option D. Check here. Second derivative test, first derivative is 0. We can find the critical point from there. And second derivative at the same point is coming to be greater than 0. It means local minimum value. Option number D is correct. Okay. Minimum value of the function given by fx equals to x. Fx equals to x. Okay. Okay, not existing, sir. I taught this question, okay, in the beginning only. Since the interval is open, check here. X belongs to open interval, okay, for the function y equals to x. We cannot have, because when x tends to 0, minimum value, okay, what will happen? Y will tend to 0. It will never be equal to 0. So there is no existing value for that. If it was in a closed interval, then answer would have been 0. But it is open interval means I cannot take any minimum value. So answer is D, not existing in nature. Okay. Now this completes our revision of AOD. So I have done all the major topics for your revision. Okay. I wish you all the best. Okay. We'll be coming back again with another session for revision of your PU midterms, PU2 midterms specifically. Okay. So I hope you are making use of the sessions. I hope you are solving all the questions. If there is any doubt, if you want something different in the sessions, comment below. But I'm trying to cover up all the concepts. That's why the session you can see is getting lengthier. Okay. So I'm trying to cover up one shot so that if you're coming for a topic, it should be complete in the session. All the concepts, all variety of questions. Okay. Questions from MCQ kind, simple question, 1 marker, 5 marker, all different marks of questions is covered in the session. Okay. So if you find the question is challenging means, and mostly actually the question that I've taken has been asked by your boards in different examination. Okay. So maybe different year, different examination, January, February, January, May also they ask, July also they ask. So the examinations are being conducted by the boards. For those questions I've taken here, solved it in front of you, giving some examples. So comment in the section if you are having any doubt, if you want something else also. So be interactive with me. Okay. Ask me your queries. I'll try to answer them. For now, this is it. We have completed our application of derivative. So keep working hard. Keep positivity around you. I'll see you in the next session. For now today, I'll try to end the session. That's it. Take care. Bye-bye.